All right. You ready to say hi to the video? What? Hi, world. There you go. Yeah. No one else wants to say hi to YouTube? Say hear yourself. This is going to be on today. Today. You ready? All right. Shout out. Here we go. Here we go. All right. So today's lesson is on complex zeros. And the reason we do this is not because my ego is so large I want 200 people to see it, right? Is so that when we do this lesson, the first time we do a lesson, it's sometimes helpful, if you care to learn it, to go back and do the lesson again. Yes? So that's why we're doing this. So today's lesson is on complex zeros. We know if it's complex, what will be a part of it? And we know that I is the square root of -1. And because the square root of -1 is not real, we say it is imaginary. Now, the skills we used before, we're still going to use now. So the skills of factoring, maybe the rational zero theorem, whatever that is. And there may be not just complex zeros. There might be irrational zeros. They may be rational zeros, and we're going to go through all of that. So step number 1, I want you to notice, what's the degree of this polynomial again? So at the end, how many zeros will we find? 4, and that's called the fundamental theorem of algebra. They could be real or complex, could be rational, irrational, or imaginary, but some combination. At the end, we're going to find 4. All right, let's look at number 1. Remember the rational zero theorem, create a list, synthetic division is the last choice, right on the list. If we can factor, that's what we want to do. So in number 1, I see, and I think you see, that it's a trinomial. So in this trinomial, I have -12 and 4. So I'm thinking, what two numbers multiply to -12 and add to negative, is it negative or positive? Negative. Add to -4. Can you think of what those two numbers are that would factor this? And signs matter, right? So I'm going to come back here. Now be careful, it's not x, but x squared. So we found the trinomial can be factored using -6 and +2. We know it's x to the 4th, so when we do the factoring, it's not going to be x, but x squared. So when we multiply it, it equals x to the 4th. All right. Now, this is not a difference of squares, and this is adding. So at this point, we're going to take each factor and make it equal to 0, because our goal is to find the zeros. And so on a graph, a 0 is an x-intercept. But in this situation, algebraically, we're finding the numbers that make the function equal to 0, right? So the first one, when I solve it, I'm going to add 6, and then I'm going to take the square root. So I know when I solve a quadratic, the answer could be positive or negative, and the square root of 6 is irrational and is prime. There's no way to simplify it. How many roots did you just find? Or how many zeros? 2. How many more to find? 2. So the second equation, we're going to subtract 2. And again, we're going to take the square root. So the answer is positive and negative, but this is different for today. What happens when you have the square root of -2? Somewhere in your past, you were told to stop and say no real solution, correct? So it's somewhere, if you ever got to the point where you took the square root of a negative number, you were told there are no real solution. Sometimes the teacher might say there are no solutions. We know that's wrong. There are solutions, but there are no real solutions. Instead, they are complex. Why? Because the square root of a negative number is imaginary. So how we write this is this. The square root of a negative number is what? Imaginary. And the square root of 2 is prime. In fact, we can put that together like this. And often we put the I in front of the square root, so it doesn't look like it's underneath the square root. So why the I? Because it's the square root of a negative number. And once you do that symbol I, it's no longer a negative number under the square root. Now that I, we brought the negative in front with the I, and now it's just 2. So the square root of 2, can you simplify it? No, right? It's prime. So we just found all the zeros. So the zeros were positive and negative root 6, and positive negative I root 2. How many zeros were irrational? If I know you're not listening to me, you will be on YouTube forever because I called out your name. Do you hear me? And the other two are imaginary. So in this case, we found how many zeros? 4 of them. 2 were irrational and 2 were imaginary or complex. There could also be rational zeros in there too. Those are your options. All right, number 2. Here we go. What's my goal again? Is to find all the zeros. The fundamental theorem of algebra says the degree tells you that. So what's the degree to number 2? 4. It's a trinomial. There's nothing they all have in common. So I'm going to factor this trinomial. 4 times negative 8 is negative 32. 31 underneath. The two numbers that multiply to negative 32 and add to 31 is 32 and negative 1. So I'm going to take out the 31x squared. I'm going to put in 32x squared and negative 1x squared. So then I can now factor by grouping. So if I look at the first two terms only, they have a 4 and a x squared in common. And I'm left with x squared plus 8. The next two have a negative 1 in common. And again, when you divide, you're left with x squared plus 8. This works because these share, right? So what's the common factor they share? X squared plus 8. And what's left over is, 4x squared minus 1. At this point, we're going to take each factor, make it equal to 0, and solve it. So for the first one, we're going to subtract 8. And then when we take the square root and solve a quadratic, it's positive and negative. Do you notice we're taking the square root of a negative number? That means it's what? Complex or imaginary. What symbol needs to be a part of it if it's imaginary? And then we have the square root of 8. We'll change that in a second. But do you see why the I is there? Because we took the square root of a negative number. How about the other side? What happens when you add 1 and divide by 4? Do you remember how simple it is to take the square root of a fraction? That's the top and the bottom. So when I solve here, I get positive and negative, the square root of 1 and the square root of 2. That is actually rational, isn't it? 1/2 and positive 1/2 and negative 1/2. What's a better way to write down the square root of 8? A simpler way. So 8 is the same as 4 times 2. So another way to write this down is 2 root 2. So I'm going to go 2i root 2. This polynomial has how many zeros? 4 of them. 2 were imaginary and 2 were rational. Still 4. All right, number 3. Can you factor number 3? Are you trying to look at number 3? Do I need to call you out to see if you know what you're doing?
Yes.
Chris, tell me how to do number 3.
Alright, so since we don't have a b, we need...
I like your courage, Chris.
Right.
Keep going.
Since we don't have a b, we need to make sure that the two terms that we're using are opposite from each other.
Okay, keep going.
In the first parenthesis, x squared minus 4.
Mm-hmm.
And then in the other one, we have x squared plus 4.
You know, Chris, you're awesome. And what you just described for me is it's a difference of squares. So the square root and the square root means I can factor this. That when you take the square root of an exponent, do you know what you're doing? You're dividing that exponent by 2. So it's x squared, and of course 16, the square root of 16 is 4. So one's x squared plus 4, and the other one's x squared subtract 4. At this point, if you need to, you can make each one equal to 0. At the very beginning, the degree of this was 4, so how many zeros are we going to find? 4. That's called the fundamental theorem of algebra. So the first one, when I subtract 4, what do you notice? when you solve this, you're going to have to take the square root of a negative number. And if you take the square root of a negative number, what symbol needs to be there? I. And what's the square root of 4? So it's not 2, but 2i. So the square root of 4 is 2. The square root of negative 4 is 2i, right? Because the square root of the negative number. The other side, when we add 4, notice in this case, again, it's the square root of 4. But do I need an I? Because it's not imaginary. So in this example, what are all the zeros? Positive and negative 2i and positive and negative 2. 2 are imaginary and 2 are rational. But they add up to 4 zeros. Each one of these numbers, if you plug it in, will give you the answer 0. Number 4. Let's see if we can do that. Chris started a great trend. The courage to talk, right? Davian, do you have that strength? Of course. Look at number 4. Can you tell me what I should do to factor it? I should try seeing if there's something they both have in common. What do they have in common? Not just that, but whenever the leading, you know the power term? If the power term is negative, I do whatever I can to make it positive so I can factor further. So I'm going to factor out a negative, so what's left over, the power term of what's left over, is now a positive number. So what you're left with is x cubed plus 8. Yes? Awesome. Now, I'm going to tell you x cubed plus 8 is called a sum of cubes. Do you know that a difference of squares kind of sounds fun, right? This is called a sum. That means you are adding. And cubes means that these are perfect cubes. Meaning what number 3 times itself equals 8? 2. And what 3 times itself equals x cubed is x. They both have cube roots. Have you ever been taught a sum of cubes? And if I taught you it, you know what it would be? Another formula back in your brain that you'll forget. So what I want to do instead is we're going to use a quick list. And the 8 is not a difficult number. So 8 is 1, 2, 4, and 8, right? Quick. And what we're going to do is synthetic division, but I'm going to give you a hint with it. Is that okay? So how many x cubes do you have? 1. Oh, I heard that, and the world heard it. And then x squared, 0. How many x's? 0, and the constant is 8. Obviously, positive 1 doesn't work because it doesn't add up to 0, but the hint is this. There's also what's called the difference of cubes. Either way, the 0 is going to come from, what's the cube root of 8? Remember what number 3 times itself equals 8? And we're not going to use 2, but we're going to use the 0 of it, which is the negative 2. And what do you notice when using negative 2? It works, right? Now, what did we just find? This function has one real 0 at what number? Negative 2. It's real, it worked, it gave me a remainder of 0. What's left over? X squared subtract 2x plus 4. I'm going to make that equal to 0. Do you see x squared subtract 2x plus 4 equal to 0? You should always think, is that actually factorable to go further? Are there two numbers that multiply to 4 and add to 2? No. So what are your options if you can't factor a quadratic? Either complete the square or the quadratic formula. Which one do you think I'll pick? And do you know why I'm going to complete the square? Because it's simple and b is a even number. So I'm going to subtract 4. And then do you remember how we find the number to add to both sides to make it a perfect square? I take the negative 2 and I do what to it? Divide by 2 and square it. So negative 2 divided by 2 is negative 1. And negative 1 squared is 1. So what are we going to add to both sides? We're going to add 1 to both sides. Now, the left side is now a perfect square, meaning what number multiplies together to get 1 and adds to negative 2? It's negative 1 and negative 1. Do you see that inside the parentheses? That's the indicator. So negative 1 times negative 1, that gives you positive 1 and adds to negative 2. But we don't write it twice, we write it squared. And on the other side, you have negative 4 plus 1. In your past, when you took the square root of both sides, you said, oh, there's no real answer. But now we know the answers can be complex. So the square root of this is x subtract 1. The square root of negative 3, well, that's I, it's imaginary, and what's left behind is root 3, and that's prime. You can't simplify it. The last step to get x by itself is to add 1. Now, oh, and this needs to be positive and negative. So if you have a real number and an imaginary number, you can't combine them together. They can only be beside each other because they're unlike numbers. So if I said, hey, what are the zeros? Well, we just said that negative 2 is a 0. Remember where that came from? And then we said 1 plus or minus I root 3. Those last two are complex. What was the degree again of it? And how many zeros did we find? One was rational and the other two were complex. All right, let's try number 5. We learn this by practicing together with a great attitude. And you don't learn something by doing it twice, whatever it is. Number 5, we're going to factor this. So, because we're in the feeling of being courageous, you ready to be courageous? Excellent. Evelyn, what would you do to factor this?
Find the common terms they have.
Well, if I look at all 4, they have nothing in common. But what other technique we use when we have 4 terms?
You do it like
We look at only the first 2 terms. What do the first 2 have in common?
x squared,
Excellent. What's left over?
x minus 2.
And the next 2 are a little bit challenging. But x and negative 2 only have one number that goes into them both evenly. And that is 1. Do these match? Do they have a factor they share? And the factor they share is x subtract 2. And what's left over is x squared plus 1 when you factor out the x subtract 2. Corey, what would you do next?
I would make them both equal to 0.
So if I take x minus 2 equal to 0, you already know that one, right? You could do that one in your head. So 1, 0 is positive 2. How about the other one? If I take x squared plus 1 equal to 0, how would you solve it?
I would subtract 1. And then I would then square root both sides, and negative 1 would become square root negative 1, and then I would try to make it complex.
So the definition of the square root of negative 1 is just I, right? So when you're taking the square root of negative 1, that's just I. There's nothing else. Just I. So what's the square root of negative 1? I. What's the square root of negative 4? 2i, right? Square root of negative 9, 3i. So the square root of negative 1 is just I. And we're solving a quadratic, so it's positive and negative. So there are 3 zeros to find. And these are the 3 zeros. 2i and negative I. Are you noticing something about complex imaginary zeros? That they always come in pairs? Like positive and negative I root 2. Positive and negative 2i root 2. Positive and negative 2i. 1 plus, 1 subtract. Positive I, negative I. That's called conjugate pairs. Complex zeros always come in complex conjugate pairs where one's adding and one is subtracting. You're always going to have that plus and minus a part of a complex solution. Okay? All right, number 6. Sarah, you ready? That means you're ready. What should I do first?
there is any common factor.
Like, look at all four, right?
If not, then I would go straight to the
All right, so I'll say there's not. Something that only number one is the only one that goes in all four. So now look at only the first two.
The common factor is x squared.
Perfect. What's left over?
3x minus 4.
Good. Look at the next two. What do they have in common?
Like 6.
Bigger.
12.
Yes. So, and you need to find the largest number for this to work. Do you know what 36 divided by 12 is?
3.
And 48 divided by 12.
4.
Do you notice how they share now the same factor?
Yeah.
So one factor is 3x subtract 4, and the other factor is,
X squared plus 12.
all right. I'll give you a moment. Dahlia is going to help me do the next step. Now that it's factored, Dahlia, what would you do next?
You make the equal to 0.
So each factor equal to 0. Can you already tell, Dahlia, one of these is going to be a real answer. One of these is going to be complex. Can you already tell? What's the indicator?
The positive 1.
So when you see x squared and you're adding, you know to get x by itself, that plus 12 is going to eventually be subtracting, right? That indicator of adding, right? In fact, if you think what number if you squared and add 12 could ever equal 0, you'd say there's none, right? There's no real number you could ever plug in to give you the answer 0, right? Some number sense. All right, so for the first one, what would you do to get the real answer?
14.
Yeah, and?
And divide by 2.
I knew you could do both at once. How about the other side? What would you do?
Subtract 12 and then do the square root of x squared.
Now, you know already that because it's the square root of a negative number, it's imaginary. Do you know the square root of 12? Is there any way to write it simpler? And you're thinking of, is there a perfect square that goes into 12 evenly? Dahlia, you're awesome. So, the fundamental theorem of algebra says the degree tells you how many zeros. So we have one real zero at 4/3, right? It's rational. And we have two complex zeros, plus and minus, and you can actually write it as 2i root 3 or I2 root 3. Both are the same thing. So 2 complex, 1 real, 3 in total. Turn the page. Who's going to help me next? Who's going to be famous? Number 7. All right, Rosie, what would you do first? I asked you, what would you do first to find all the zeros?
I want to group.
Now, can I give you a hint already? What's the degree of this? 5. How many zeros are there to find? 21. That's not the fundamental theorem of algebra. The degree is 5. How many zeros are we going to find? 5 of them. All right. So what did you say, Rosie? You're going to factor by grouping?
Yeah.
So what do they have first two have in common?
X to the power 4.
And then what's left over?
2x minus 5.
Okay, look at the next two terms. What can I factor out in front so that the two factors would match?
Negative 1.
So if I factor out a negative 1, do they share the same factor?
Yes.
So they share the factor 2x subtract 5, and what's left over is x to the 4th subtract 1. Clarissa's going to take over. So at this point, what would you do next?
You equal to 0.
So we have 2x subtract 5 equal to 0. Now, for this one, it's okay to make it equal to 0, but I'm actually going to factor it further, Clarissa, and make it equal to 0. How do I factor x to the 4th subtract 1?
X squared plus 1 and x squared.
So x squared plus 1 and x squared subtract 1. Good job. That's called the difference of squares. So really, I have one answer here, add 5 and divide by 2. That's real. I also have another equation, x squared plus 1 equals 0, and another one, x squared subtract 1 equals 0. Clarissa, can you already tell me which one is going to give me a complex solution? Yeah, because if you square any number, add 1, it could never equal 0, right? It can only be imaginary. So how would I solve it then? What would I do first?
You subtract 1.
And then?
It's I.
And it's positive and negative I, right? Because the square root of negative 1 is I. How about on the other side? What would you do? Is this one going to be imaginary?
No.
So it's just positive and negative what? So if I said, hey, what are all the zeros? Remember how many we were going to find? 5 of them. Did we find 5? We found 5 over 2, positive 1, negative 1, positive I, and negative I. How many zeros did we find? And 3 of them are real and 2 are complex, but together they make 5 numbers that if you plug it into the equation, make it equal to 0. Number 8, we ready to be courageous? Marilyn's going to help me with number 8. I'm listening. I'm so listening. The world is listening. Tell me. See, that's how big of an ego I have. The world is listening when this gets uploaded this morning. Number 8. All right, try. What would you do? And what's left over? X plus 7? Is that what you said? I think that's what you said. That's what my ears heard. And then the next two? And you know why we take out a negative one? So they can match, right? We want those to match. So finish off the factoring. All right. Nancy, you're going to take over. Do you know that when I solve this, that one answer is simple, right? X plus 7, what 0 is going to come from that? Negative 7, right? Nice and simple. This one, an x cubed, subtract 1, it's going to take us back to the front page. This is called a difference of cubes. All right. So for a difference of cubes, I could give you a formula like the quadratic formula and other formulas. You don't need another formula in your head, right? So instead, we're going to make it simple. And the reason it's simple is because the list to create for 1, there's only one number that goes into 1, which is, so it's either positive 1 or negative 1. Super short list. We're going to do synthetic division instead of the formula. So we have 1x cubed, 0x squared, 0x, and negative 1. Because it's a difference of squares, it's actually going to be positive 1 and not negative 1 we're going to use. But if you pick the wrong number, that meant the remainder is not 0. It should have been the other one, right? So if you picked negative 1 and it didn't work because it had a remainder not 0, then you pick positive 1. So Nancy, how do I do this? So 1 times 1 is 1, add 1. 1 times 1 is 1, add. A lot of 1s, isn't it? And there's a remainder of 0. So what I'm left with, Thomas is going to help me. What am I left with?
X cubed.
Close. Do you know that when you divided, your dividend was x cubed, so your quotient's going to be 1 degree less. So try again.
X squared.
Yep.
Plus X.
Yes.
Plus 1.
Excellent. And we're going to make that equal to 0. Now, I have two options. I do not, Thomas, you're going to help me. I do not have the option of factoring here because it's not factorable to solve this quadratic. So you're either going to complete the square of the quadratic formula. What are you going to do? All right, do you want me to pick for you?
Yeah.
Excellent. What I notice here is that b is an odd number. So if I divide by 2 and square it and do that work, it's going to be a lot of fractions. So we're going to use the quadratic formula, and Thomas is going to help me through it. So one thing to know for the quadratic formula is that a equals 1, b equals 1, and C equals 1. Do you see that's already there? Isn't that kind of cool? ABC, 1, 1, 1, right? So, do you remember the quadratic formula, Thomas?
Not really.
All right, we're going to do this. You ready? There's a negative boy who couldn't decide whether to go to the dance because the boy was square, so he missed out on 4 awesome cuties, and it was all over at, the dance was all over at 2 a.m. So, Thomas, what's B? So we start with negative 1 plus or minus the square root of B squared. What's 1 squared? 1. Subtract 4 AC. All over at 2 a.m. Now we're going to simplify this. So, do you know that there's a name for what's underneath the square root sign of a quadratic formula? It's called the discriminant. I don't know if you ever heard of that. But the discriminant tells me if the answer is real or complex. Because what's underneath the square root sign, if it's negative, what letter needs to be a part of it? That number. I, right? So, when I look underneath the square root sign, it's called the what again? The discriminant, and it tells me if the answer is real or imaginary. So, what's 4 times 1 times 1? So you're going to go 1 take away 4. Square root of negative 3. What does that tell you about the answer? Is it going to be real or complex? Excellent. Now, what is the square root of negative 3? Well, because it's negative, what symbol do you need? And the square root of 3, can you simplify it? Nope. Oh, what am I missing in front? Negative 1. All over 2. So I'm going to just put a box around it because I got out of room. But how many zeros was I going to find? Do you know what another 0 is as I put a box around it? So negative 7 was easy. Positive 1 gave me a remainder of 0. And then the last 2 are complex. By knowing the fundamental theorem of algebra, I didn't forget 1, right, in the corner. I knew I had to find 4 of them. And 2 were rational and 2 were complex. All right, 9 and 10. And it's going to end the video, sadly. So, 9 and 10, and then we'll pick up this tomorrow, okay? So who have I not picked on that's going to help me? You ready? All right. Superhero Nicholas. Nick, are you ready? Well, I'm going to help you. So, in number 9, Nick, the first thing I look at is, do they have anything all in common? And the answer is no. If I try to factor by grouping, if I take out what they have in common, the factors are not going to match. I'm telling you right now. I think. Or will they match? Well, then why am I saying they won't? Nick, tell me. Remember, the rational zero theorem is your last, right, resort? Are you ready? You don't want me to call you out, do you? Yeah, you. I know, I knew, I see, what? Do you finish number 9? Let's go. We got this. Nick, help me. Take the first 2 terms. What do they have in common?
X squared.
So we factor out an x squared, and you're left with 2x subtract 5. Look at the next 2 terms. What do they have in common? And when you divide, you're left with?
4x negative 5.
Close. 8 divided by 4 is? 2. Right. And negative 5. And you're right. That's good news, isn't it? 2x subtract 5, and the other is x squared plus 4. My goal is to find all the zeros. Because the degree is 3, how many zeros are we finding? 3. That's called the fundamental theorem of algebra. So, easy. 2x subtract 5. What 0 comes from that, Nick?
2x minus 5. 5 over 2.
That's right. Easy. The next one, x squared plus 4. Do you already have a sense what type of solution it's going to be? Because it's x squared plus 4. They're going to be complex, right? So to find the complex, we're going to subtract 4. And then what? Now when you take the square root of a negative number, it's positive and negative, and what needs to be a part of it? And the square root of 4 is 2. So instead of 2, it's 2i. So what are all the zeros? 5 over 2, positive and negative 2i. All right, last one for the video. Number 10. Eduardo, you ready?
That's right. I guess. Maybe you can try grouping.
So the fundamental, you're right, I could try it. The fundamental theorem of algebra, the degree is 3. How many zeros am I going to find? 3. So if I did try grouping, the first two have x squared. The next two have 16. What's 48 divided by 16? That's disappointing. So why can I not go further at this point? Do the factors match? So I can't factor by grouping. So, Eduardo, tell me all the numbers that go into 48 evenly.
1, 2,
3. Keep going. Don't stop. 4. Don't stop.
6,
Correct?
8,
Yes? Now we're working backwards.
12,
Yep.
16, 24, 48.
All right. So it's a big number in terms of lots of factors. So let's see if we can make this easier on ourselves. So we have 1, negative 2, 16, and 48. Did I forget one? 1, negative 2, 64. Does this add up to 0? You don't think so? It definitely does not add up to 0. So what we need to do now is take numbers off the list and see if the remainder is 0. If you pick a number that doesn't give you a remainder of 0, then you erase it and then start again with a different number until it works. I'm going to help you, Eduardo. You ready? The number that works is negative 2. That's because it's magical. No, it's just the way, right? That I could make you go through it for 10 minutes. Or I'm going to right now tell you negative 2 on the list works. And you would find it eventually because that's the number that gives you a remainder of 0. Eduardo, how do I do synthetic division?
So 1 plus 0 is 1. 1 times negative 2 is negative 2. So negative 2 plus negative 2 is negative 4. Multiply negative 2 is 8. 16 plus 8 is 24. Multiply by negative 2 is 8.
So I didn't lead you astray, right? It works? So what did we find out already? Our goal is to find the zeros. So 1 0 we found is negative 2. Yes? All right. Daniela, what would you write down? The answer. How would you write it down?
I would write x squared minus 4x plus 24.
Now, if this was factorable, two numbers would multiply to 24 and add to negative 4. And it doesn't exist. There's nothing there that would factor it. So what are your two options? Complete the square or quadratic formula. What option do you think I would pick? You know why? It's a simple trinomial, meaning A is equal to 1. And the B is an even number, so when you divide it by 2, it makes it simple. So to complete the square, is it okay if I support you? I'm going to first subtract 24. Next, Daniela, what's B equal? And I'm going to do two things. Do you remember what two things you're going to do to complete the square? Divide it by 2 and square it. So negative 4 divided by 2, and then negative 2 squared. So negative times a negative, right? Positive 4. So we're going to add what number to both sides? And that number we add to both sides will always be positive. Now, when I factor the left side, guess what number I'm going to use to factor it? Negative 2. Because negative 2 times negative 2 is 4, and it adds up to negative 4. Now, instead of writing x minus 2, I write it as x subtract 2 squared. On the other side, negative 24 plus 4 is negative 20. If you take the square root to both sides, what's going to happen? The answer is going to be positive and negative, but because of that negative, it's now I. Now, the next step, we're going to simplify it. Is there a way to simplify the square root of 20? What number goes into 20 evenly? That's a perfect square. And? So the square root of 4 is, and what's left over is root 5. So this answer is really positive or negative 2I root 5. We still have one more step. How can I get x by itself? Close. So you add 2. Remember that a real number and imaginary number are unlike. So you can't combine them together. So what are all the zeros of this? So if I combine them together, what was the degree again? So 1 0 is, and the other 2 are complex. You don't have to write them separately, but I think then you will actually see what I'm trying to get at. One is 2 plus 2I root 5, and the other is 2 subtract 2I root 5. If you would graph number 10, do you know how many x-intercepts you'd see on the graph? 1. Imaginary, like your imaginary friend, right, is there but not there. You know what I mean? So on the graph, you would not see that imaginary 0. Only the real one. But if I said, what numbers would you plug in, and when you simplified it, would give you the answer 0? There are 3 numbers that would work. Real and complex. You ready? Mr. G Math, over and out. You're famous.